Okay, example 4, we're taking a look at this last form here, x squared minus a squared. So this is the form for secant. So we'll go ahead and let x equal... So this is one where we've got two different numbers we're working with here. So we want to... Ultimately, we want to change this 4 into a 36. So we can accomplish that by having the coefficient on our secant substitution get rid of the 4, so we'll put 2 in the bottom, and introduce a 36, so we'll put a 6 in the top. And that will do it for us. And you can see also that this will simplify into 3, and then 3 squared is 9, 9 times 4 is 36, so that checks out. So we'll just go ahead and write this as 3 secant theta. So then dx is 3 secant theta times the tangent of theta d theta. So then this will turn into, let's see here, integral of x squared becomes a 9 secant squared theta. The inside of our square root will have a 36 secant squared theta minus 36, so that matches up nicely. And then the dx will become a 3 secant theta tangent theta d theta. And of course, the inside of the, so the entire square root, this becomes just 36 tangent squared theta, which is, of course, just 6 tan theta when we square root it. Okay? So it looks like what's going to happen here, we can do some simplifications here. The 3 and the 9 will reduce to a 6 in the bottom. But not a 6, I'm sorry, to a 3 in the bottom. And then the tan theta in the top will cancel with one of the tan thetas there. And then we have a, let's say, one of the secants in the top will cancel with one of the secants in the bottom. So that's a lot of cancellation right there. So what's left over here should be nothing in the top but a 1. We've got a coefficient of 3 here and a 6 here. So 3 times 6, we got an 18. One of our secants remains. And then from our, yeah, that looks like it's it, actually. So this fraction bar was a little bit too big, but it looks like it is 1 over 18 secant theta. So I can pull out the 1/18th, and then of course 1 over secant is just cosine. So this is 1/18 the cosine of theta that we are integrating, which is of course just 1/18 sine of theta plus c. Okay, and then since our substitution here was 3 secant theta, we can go ahead and pull back using the triangle. So drawing a triangle, we know that secant of theta is x over 3, which means that the cosine of theta is 3 over x. So place a theta somewhere on one of your two non-right angles. And then cosine is the ratio adjacent over hypotenuse. So then this third side length, using the Pythagorean theorem, should be x squared minus 9. Now, you'll notice here that x squared minus 9 does not perfectly match this. But notice that 4, if you factor out a 4, you're left over with x squared minus 9, and so that piece does match. So that's not a contradiction, it's just, it's a little bit harder to see how it all comes together. Okay, so that looks good. So then lastly, we actually have a sine of theta, so again, using the right triangle we just built, sine of theta is opposite over hypotenuse. So this is the square root of x squared minus 9 all over x. And it's 1/18 of that, so we've got square root x squared minus 9 all over 18x plus c. as our final answer.